This is Kyle. He's up in a tree. We don't want him to fall because gravity, which has an acceleration of negative 9.8 meters per second squared, will pull him down to the ground. Because he's so high up, he has more potential energy, and henceforth, more kinetic energy if he were to fall. We can also see an example of this with the swing.
As Thrin rises, her potential energy increases. When she's at the bottom of the arc, her potential energy is converted into kinetic energy. When pushing at the very end of the arc, she goes even higher, and that is constructive interference. When you push before she reaches the end of her arc, that is destructive interference, and she does not go as high.
Newton's first law states that an object in motion will remain in motion unless acted upon by an outside force. Hitting a tennis ball with a racket shows us an example of projectile motion. Gravity acts on the ball, a force that causes downward acceleration. The horizontal motion of a projectile is the result of Newton's first law.
The seesaw is an example of a simple machine called a lever. Simple machines change the size, direction, or distance of a force. In this case, it increases the size of the force compared to how much force you put in and how much force you get back out.
In a vibrating guitar string, the ends of the strings are notes. By changing the position of the ends through the frets, the guitarist changes the pitch as well. My dog is staring at me, disappointed that I'm listening to my music at such a loud volume. I need to lower the decibels I'm subjecting my eardrums to before I get permanent hearing damage.
This is an example of Newton's first law. If I had not acted upon that ball, it would stay at rest. And if gravity were not acting upon the ball at all times, it would keep going forever in a frictionless environment. This is an example of refraction. The water is more optically dense than air, which causes that breaking illusion you see here.
This clock is an example of a parallax because the time appears to change with your relative location.
Work is defined as a force moving an object parallel to the force over a distance. The first clip is not an example of work since the car does not move, but in the second clip, the car does move, so that is an example of work.
If we look at the mileage before and after we've taken our drive, we can deduce the distance we've traveled. When the red hand that points to our current velocity goes up, our acceleration also goes up. The velocity is how many miles per hour we are driving.
The microwave is an example of heating through radiation. The microwave shoots microwaves to excite the particles in the object you are heating.
These bulbs can be dimmed because they are incandescent. Electricity heats up a filament until it produces light, which is how they work. The heat required to melt an ice cube is called its melting point, which is the point at which a solid melts into a liquid. As it reaches its boiling point, which is when the liquid will turn into a gas, the water will become vapor and evaporate.